This is a story of a change that is hidden from sight, yet it is gripping every aspect of our lives. A reality that we feel every day in the form of extreme weather, unseasonal rains, and melting glaciers, but perhaps we do not comprehend its full complexity and depth. This is the story of climate change and the rising temperature of the Earth. When we talk about climate change, we don't just mean the weather getting hotter. It is a much broader and deeper issue than that.
Its real meaning is the long-term changes in the Earth's average weather, i.e. temperature, rainfall patterns, and wind directions. This is not a matter of a few years, but a variation spanning decades and centuries that is altering the entire system of the planet. History tells us that the Earth's climate has always been changing. Ice ages came and went naturally due to factors like slight changes in the Earth's orbit or fluctuations in solar activity. But the real problem is the speed of this change.
The changes that naturally took thousands of years have been occurring with incredible speed over the last 2 centuries, especially since the Industrial Revolution of 1850, due to human activities. The statistics paint a worrying picture. Compared to the pre-industrial era, the Earth's average temperature has risen by about 1.1 degrees Celsius. This 1-degree increase might sound minor, but for a vast and complex system like the Earth, it is a sign of a severe fever.
Future estimates suggest that if we do not reduce the emission of gases that warm the atmosphere, this increase could reach 2 to 5 degrees Celsius by the end of this century. A 5-degree increase could make most parts of the planet uninhabitable. Why is this happening? What is the science behind it? The answer lies in the concept of the greenhouse effect. This is naturally an essential process.
Certain gases in our atmosphere, such as carbon dioxide, CO2, methane, CH4, nitrous oxide, N2O, and water vapor, act like a blanket. These gases trap the sun's heat in the atmosphere as it reflects off the Earth and heads back into space. If this natural blanket didn't exist, our Earth would be so cold that life might not be possible, and the average temperature would be around minus 18 degrees Celsius. The problem arose when we started making this natural blanket much thicker. Over the last 2 centuries, by burning fossil fuels like coal, oil, and gas excessively, we have increased the amount of these blanket gases in the atmosphere to dangerous levels. Before the Industrial Revolution, the concentration of carbon dioxide in the atmosphere was about 280 parts per million, ppm. Today, it has surpassed 420 ppm, which is the highest level in the last 800,000 years. These extra gases are trapping additional heat in the atmosphere, causing the Earth's temperature to rise continuously. The burning of fossil fuels is the biggest cause, but it is not the only culprit.
Deforestation aggravates the problem in 2 ways. First, when trees are cut and burned, the carbon stored in them is released into the atmosphere as carbon dioxide. Second, we destroy the very natural machines that absorb carbon dioxide from the atmosphere. It is estimated that about 11% of global greenhouse gas emissions are due to deforestation and changes in land use. Additionally, the agricultural sector also plays a major role.
Nitrogen-based fertilizers used in crops release nitrous oxide, N2O, a gas that is about 300 times more potent than carbon dioxide. Livestock farming, especially cattle and buffalo, releases methane, CH4, during digestion or when their manure decomposes. This gas is 25 times more effective at trapping heat than CO2. Rice paddies, which remain flooded, and urban landfills are also major sources of methane. A fundamental reason behind all of this is also population growth, which means greater use of resources and higher emissions. This pertains to the lower layer of the atmosphere, the troposphere. But in the upper layer of the atmosphere, the stratosphere, humans had created another crisis related to the ozone layer. Ozone is a molecule, O3, made of 3 oxygen atoms which forms a thin protective layer in the atmosphere.
This layer absorbs the sun's extremely harmful ultraviolet rays, especially UVB and UVC, and protects life on Earth from skin cancer, eye diseases, and other dangers. In the 1980s, scientists discovered that a large hole had formed in this layer over Antarctica. The cause was chemicals called chlorofluorocarbons, CFCs, which were commonly used in refrigerators, air conditioners, and spray cans at the time. These chemicals rise into the atmosphere and break down ozone molecules. Here lies a piece of good news and an important lesson.
The world took this threat seriously and in 1987 signed a historic international treaty called the Montreal Protocol. Under this treaty, all countries agreed to phase out the use of CFCs and other ozone-depleting chemicals. Today, the use of these chemicals has been almost completely eliminated, and the ozone layer is slowly recovering. This is proof that when there is global commitment and science is heeded, we can solve major environmental problems. However, it is important to remember that the ozone problem was not a direct cause of global warming. They are two separate environmental issues, although some indirect connections exist. Now, let's return to the effects of climate change that we are witnessing with our own eyes today. The rising temperature is just the beginning. Its first and most obvious consequence is the melting of ice. The ice sheets at the poles, i.e. the Arctic and Antarctica, and the glaciers on mountains are melting rapidly. The summer ice in the Arctic Ocean is reaching record low levels every year.
Billions of tons of ice from Greenland and Antarctica are melting and flowing into the sea each year. Pakistan, also known as the Third Pole for having the third largest ice reserves after the polar regions, is seeing its Himalayan and Karakoram glaciers shrink rapidly, which are a vital source of water for our rivers. When this melted water enters the ocean, it has two major consequences. One, obviously, is that the sea level is rising. The second reason is that as the ocean water itself gets warmer, it expands. This is called thermal expansion. Due to both these factors, the average sea level has risen by more than 8 inches in the last century. Even this seemingly small increase causes devastating floods in coastal areas during storms. If all the ice in Greenland and West Antarctica were to melt, the sea level could rise by several meters, which would submerge all the world's major coastal cities like Karachi, Mumbai, New York, and London. Here, another surprising and seemingly contradictory theory emerges, that global warming could also lead to a new ice age.
How is this possible? It is related to the global ocean circulation system, also known as the conveyor belt. A very important current in this system is the Gulf Stream, which brings warm, salty water from the equatorial regions to the North Atlantic, keeping Europe's climate mild. When this water reaches the north and cools, it becomes denser, sinks deep into the ocean, and then flows back south.
The theory is that when a massive amount of cold, fresh, less salty water from Greenland pours into the ocean, it will form a layer on the surface, preventing the warmer, saltier water below from cooling and sinking. If this sinking process slows down or stops, the Gulf Stream will halt, cutting off the supply of heat to Europe and North America. This could lead to a severe cold spell in these regions, potentially heralding a mini ice age.
Scientists are observing a cold region in the North Atlantic called the cold blob, which some experts believe is an early sign of this circulation system weakening. Additionally, we are seeing an increase in both the frequency and intensity of extreme weather events. In some places, intense rainfall in a short period is causing flash floods, while in others, prolonged droughts are leading to famine. Hurricanes, cyclones, and typhoons draw energy from warm ocean waters, and they are now becoming more intense and destructive. These effects are not limited to land.
The oceans absorb about a quarter of the carbon dioxide from the atmosphere. When CO2 dissolves in water, it forms carbonic acid, which is increasing the acidity of the oceans. This acidity is fatal for countless marine organisms like coral reefs and shellfish that use calcium carbonate to build their shells. Warm water and acidity combine to cause coral bleaching, where corals lose their color, turn white, and eventually die. The cumulative effect of all these changes is impacting ecosystems, biodiversity, and ultimately us humans.
Millions of plant and animal species are facing the threat of extinction. Food and water supplies for humans are becoming uncertain. Intense heat waves are proving to be directly lethal. Mosquito-borne diseases like malaria and dengue are spreading to new areas.
The economic devastation from natural disasters has reached billions of dollars, and above all, a new crisis of climate migration is emerging, where people are forced to leave their homes due to rising sea levels, drought, or recurring floods.
This picture is certainly dark, but despair is not the solution to this problem. It is late, but there is still time to avoid the worst outcomes. The path forward consists of two fundamental parts: mitigation, which means reducing gas emissions, and adaptation, which means learning to live with the changes that are now inevitable. We must end our reliance on fossil fuels for energy and adopt solar, wind, and other renewable energy sources. Conserve energy, protect forests and promote afforestation, and encourage sustainable agriculture.
At the same time, we must prepare ourselves for the coming changes by building better flood protection systems, managing water resources more effectively, and developing infrastructure that can withstand extreme weather. At the international level, the 2015 Paris Agreement was a significant step, but its implementation is still very slow. This is not just a fight for governments, but for